Okay, translations. A translation slides a figure from one position to another position without turning it. The pre-image means the original image. The image is the new image, and you'll write it with an apostrophe. Okay, the apostrophe is called the prime or the new shape. And I'll explain more how that works. Okay, this is how you will read it. It says your coordinate xy, the arrows, the yields. You're going to add x plus a, and then your y plus your b. For example, if you notice, the blue one does not have the apostrophe, so that's your pre-image. And then the green one is your new image. And then if you also notice that the green one has the apostrophe. Okay, so first example, you're going to graph JKL. So the first thing that you should do is to graph the points they give you. Okay, this first example, or at least the first picture, I have it graphed for you already, and then it tells you where you're moving it. Okay, if you notice, it says you're translating it 2 to the right and 5 units down. Okay, and in the picture it shows you how they did it. So we're on 1, 2 units right, 1, 2, 3, 4, 5 units down. So what you're going to do is do it for each coordinate that they give you. So 2 units to the right, 5 units down. 2 to the right, 5 down. But you don't have to draw the lines just like I did. You can just count. Okay, so whenever you move your triangle or you're translating it, so 2 units, 5 down, 2 to the right, 5 down, 2 to the right, 5 down. Okay, all you really do need to plot is where your end points will fall. So that's where you'll get that green triangle. Okay, you don't have to do any of this, this extra stuff. Okay, also notice how they have J prime, K prime, L prime. That's what the apostrophes. Okay, so I have a graph here for you to try. So make sure you graph those points first that they gave you for A, B, C, D, or sorry, it's just a triangle ABC, and then you're going to translate it 4 units to the left and then 3 units up. All right, example 2, we're going to go for the table, writing it out the algebraic way. Okay, so here we have our triangles vertices where x is -1, -2. So I'm going to go ahead and put it into our table. So -1, -2. Y is 6, -3. Oops, forgot my letters. And z, 2, -5. Okay. All right, so if you notice here, it says we're going to translate 2 units to the left and 1 unit up. Okay, if you think of a number line, if you're going 2 to the left, we know that we're going to have negative, okay, or minus. And then if you're going up, okay, think of your y-axis. If you're going up, we know we're going to have a positive. So that's where this algebraic rule comes from. Okay, so positive and a negative make a negative. So here we're adding x plus our -2. since we're going to the left 2 units, and then y plus 1 because we're going up. Okay, I don't like having the two signs together. So a positive and a negative make a negative, so it's really y minus 2, and then y plus 1. So all you're going to do is plug in your numbers. Okay, so my x is negative 1, so negative 1 minus 2, and then my y was negative 2 plus 1. Okay, I got that from the original coordinates, so negative 1 minus 2, we get a negative 3. Negative 2 plus 1, we get negative 1. So that is my new vertice. I went from negative 1, negative 2 to negative 3, negative 1. Okay, you're going to repeat the process. So 6 minus 2, negative 3 plus 1. So we get 4, negative 2. And then the last one, 2 minus 2, and negative 5 plus 1. So we get 0, negative 4. Oh, I should have put a coordinate grid on to graph these. Oh well. Okay, so now you will try. We have the quadrilateral ABCD has vertices at A0, 0, B2, 0, C3, 4, and D0, 4. Determine the vertices of the quadrilateral A prime, B prime, C prime, D prime after a translation of 4 units to the right and 2 units down. All right. Now you're going to go into where they show you both shapes, and you have to figure out the algebraic rule for it. Okay, it says a computer image is being translated to create the illusion of movement. Use an algebraic representation to explain the effect of the translation from point A to point B. All right, so we're looking at point A. Point A, we're at 3, 3. Okay, and to point B, we're at 2, 1. So we need to see how our point A moved to point B. Okay, there's a couple ways you can do it. Here, I'm going to do it in the first graph just because I can see where I'm going. I'm going to plot where 2, 1 is. So this is where my B is. Okay, so what it looks like is that we went down 1, 2 units and to the left 1. So down 2 gives me a negative 2. To the left 1, we get a minus 1. Okay. Left because on the number line, if you go left, you're towards the negatives, and then it's negative 2 because we're going down. Okay, so algebraic rule, x, y yields to where my x, okay, so x is our horizontal, we subtracted 1, oops. And then y is our vertical. We went down 2, so it'll be minus 2. So this is my algebraic rule. From point A to point B, I went xy yields to x minus 1, y minus 2. Okay. There's your you try. You're going to look back to that example AB. So now if your point was at 1, 5, so you have a new point for your starting. Use an algebraic representation to explain the effect of the translation from point A to point B. So point B still stays at 2, 1. but now your point A is at 1, 5. So go ahead and write your algebraic explanation. I will see you guys later. First period, I'll see you for +1. The rest of you guys, I will see you tomorrow, and we'll be working on reflections tomorrow.